Hello everyone. In this lecture we are going to learn about Material Requirements, ASME Section 2 versus Section 8 Division 1 Subsection C. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scootoid.thinkific.com.
All the sections where you have seen the material part. What are the sections? Till now, whatever you have studied, apart from subsection C, where that material requirement you have seen, the requirement pertaining to material, in what all sections are there? UG, yes, in UG also lots of requirements related to materials are given. And this is section 2. Section 2 is specifically for material. Section 2 part A, B, C, D, all are for materials, right? So what we cover in section 2, what we try to cover, what are the things which are available in section 2? Okay. Chemical plus mechanical properties, steel making practices. Yes, in specifications we'll see that. Means we have seen that. So allowable stress values, very, very important. That is covered in section 2 part D. Great. Supplementary requirement, dimensional tolerance also, yes, that's there. Material chart for external pressure, yes. So lots of things are there. Now, what we expect in this subsection, what do you think is missing, which we are going to cover in subsection C? Why this subsection C is required? What do you think? Any point which you can tell why or what we will be seeing in subsection C? Why heat treatment and simulation? Yes. Why heat treatment is not covered in section 2 in any of the parts? It's coming directly in subsection C. Why? What is the reason? So wherever like in part A, there is specification for carbon steel. So in that specification, it can be mentioned, right, that what should be the heat treatment for that material. So like carbon steel, if you're talking about 516 grade 70, which is the most widely used, have you seen that heat treatment requirement covered there? No. So why it's not there? Why it's specifically coming into subsection C? What might be the reason? So if we know the structure, how ASME is trying to structure things, then we'll be able to find things very easily, and we'll also able to quickly go whatever section where we'll find the details. That will be pretty clear in. So general requirements. So if it's general requirement, then it can be covered in section 2, right? Each construction code is having different requirement. So the basic thing is, see, material is same for all the codes. Okay, that is the reason we have section 2. In section 2, we have listed all the materials. Okay, so the same section will be referred by different codes. Now the code will provide some additional requirement, like what are the materials. See, all the ASME materials are not used in all the sections, all the design codes, right? So ASME is having listing of lots of material. What are the materials which are acceptable in that code? That will be given in the code. Okay, so whenever I'm saying code, I mean design code. What are design code? The codes which give requirement to particular kind of equipment, like section 1 talks about power boiler. Okay, section 8 division 1, all kind of pressure vessels, right? Unfired. So section 3 for nuclear. So there are different categories for that. These design codes are made, and there are some subsections like section 2, section 5, section 9. These are supplementary. They will be required in each and every design code. I hope you got that point. So now talking about the structure of section 8 division 1, just to give you a little brief, We covered introduction part in U1 to U5. Then there is subsection A, which talks about all the general requirements applicable to pressure vessels. Then there is subsection B, which talks about fabrication related requirements, right? Then this subsection C comes, which talk about requirement pertaining to material. Okay. So material requirement we cover in subsection C. Then there are mandatory appendices, which address very specific subject, like flange design, different other formulas available, which is not covered otherwise. Okay. So lots of additional things are, and this is mandatory, we have to follow if it is applicable. Yeah. UHX, great. Non-mandatory appendix. These are the recommended practice. Okay, that is good in recommended practice suggested by code. So whenever as a designer, we are getting some recommendation by ASME, definitely it becomes a clause which should be followed by us. Okay, because that is the best reference we can get, right? So if we are following non-mandatory appendix for any calculations, nobody can question that. If you have taken that calculation from somewhere else, people may question that why not non-mandatory appendix, which is already the recommendation by ASME, why you are not following that. So even though it's just a recommendation for us as a designer or as a quality person or as a fabrication engineer, it becomes a mandatory requirement. Okay, great. So now in subsection C, as we discussed, there are some requirement pertaining to different classes of material, which is covered here, which is very specific to code. Okay. So what different sections are there in this? In subsection C, there is part UCS, which talks about carbon and low alloy steel. The name is a little bit confusing. It's UCS. CS means carbon steel, but it covers also the requirement of alloy steel. Okay, so both are covered here. Then for non-ferrous materials also, part UNF, UHA for high alloy steel, then cast iron, very rarely used. Then cladding, if some cladding is there, we have to refer this UCL and note down the additional requirement and apply in the drawing or design. Okay, it may be related to well detail or even design related. So ductile iron, ferritic, so lots of different, typically we don't use all that, but it may become important, case to case basis. Like if you have made your vessel with layered construction, 2 plates combined, then you have to refer ULW for layered construction. Okay, you all familiar with UHX for if I have shell and tube heat exchanger as a pressure vessel, because that is also a pressure vessel, right? So we can design that as per section 8 division 1, but there are some additional rules applicable to that. Okay, great. Then impregnated graphite, that is also a very different kind of material. It's a proprietary material. Okay, so it's not everybody can produce. It's very difficult to get and very specific uses for this. So now this has also become part of ASME section 8 division 1. Great. So again, the same question, why the material, what are the missing things which are not there other places, and we want to cover here. So we mostly have discussed that. See that in part A, there are specifications of material. So if I have to purchase a 516 grade 70 plate, I can just name that material specification, and that will be sufficient because that specification given by ASME covers all the requirement in very detail. So we don't have to write that steel should be killed, should be fine grain. All those things are already there. What should be the heat treatment process, whether normalizing is required or not. Apart from that, whatever is there in specification, if any additional, you also see that there are some supplementary requirement given in the material specification. So if for our job, if that requirement is important, then we have to mention that separately. Okay, then only the plate manufacturer or the supplier will do that testing, or so we have to mention that those additional requirements. So then if we have to mention, then it becomes as a we have to prepare a material specification. So first we'll list down the 516, and then we can add that these are the additional requirements which should be that done. Yeah. So Ravindra is absolutely right. Supplementary, like if there is NACE requirement, so there are lots of additional requirement which get added. Okay. So carbon equivalent shall be restricted if there is NACE requirement. Hardness should be restricted. So lots of additional requirement comes based on what is my application. Okay. So part B talks about non-ferrous. Part C related to welding rods, electrodes, filler wells. Part D talks about properties of material, right? So we get allowable stresses, yield, tensile, modulus elasticity, density, all physical and mechanical properties we get from here. Okay. So part A, B, and C, these are mainly required or mentioned when we want to order. So they cover the ordering information. Okay. While part D, we as a designer, we all the time use part D because that covers the design related properties, mechanical and physical properties. So this is what we have got from section 2. Okay. So now what is there additional in subsection C? We will get what are the specifications of ASME which are permitted to be used in section 8 division 1, right? So like we said, that not all the material specifications can be used in section 8 division 1. So which can be used, which cannot be used is given by this. Okay. Post-weld heat treatment requirements. PWST is very specific requirement. It will change based on material. It will change based on the thickness. It will change based on the code which you are using. So it has to be there in code, in the design code, right? And for each and every material, we are going to see how that, what should be the holding temperature, what should be the holding time for post-weld treatment, why actually we perform post-weld treatment. That is also we are going to cover. Okay. Then MDMT calculations. See, MDMT calculations is also very important if you are familiar with problems associated with low temperature. Then MDMT is very, very important. So there are many other things also, but basically these three are the requirement for which we have to refer subsection C. Okay. So finally, what happens? We have to combine all those requirements. Section 2D, then whatever is given in subsection A, whatever is given in subsection B, all that combined becomes the complete requirement of material. Okay, none of the portion will cover all the requirements. It's all scattered based on the purpose. So that is the reason we have to be very good in studying code so that we can find out these requirements. Okay. So now we are starting with UCS requirement. So if you have to see what are the material specifications which are permitted, there is table UCS 23, which covers all the materials which we can use in section 8 division 1. Okay. How many of you have seen that table UCS 23? Seen? So now one question. Can I use any other material than what is given in UCS 23? Can I use any other material which is not there in UCS 23 table? Can I use that? So if you read UCS 5, then the start code will say that there are some exemptions. Yes, it has to be matching. So that is, so anybody remembers what clause I can use if I have to qualify some other material? So it's in UG 10. Okay, if you refer UG 10, you will get that qualification of the material which is not there. So even though code gives you uh, provisions, the acceptable specifications, but there is also provision if you're not able to meet that. But it's very difficult process, guys. If you have to qualify a outside material, a number of things you'll have to do. It's very, very, very difficult. Okay. So better than that, if you can find whatever is there in UCS 23, you have to use that. Otherwise, it will become a complete different study. Okay? You have to compare each and every clause of that specification. And for that, the relevant clause of material which you have taken, it must be some other standard, right? So for each and everything, you have to find the conformance. It has to confirm. Okay, so we have to do lots of additional testing also, or some things which are not possible to get as a testing, which has to be like heat treatment, what happened, which type of furnace used. So those things should be there available as in the TC. So you need verification of each and everything, then only it can be qualified. Okay. So it's very tricky process. Okay. But yes, it's possible. Like all the other things, specifically, you will find some of the exemptions through which you can go, but that path is going to be difficult. Okay. So if carbon and low are still greater than 0.35% carbon, can I use them in Section 8 Division 1? If I have a alloy or carbon steel where the carbon percentage is greater than 0.35, we cannot use it. That is what UCS 5 tells us. We cannot use a carbon or low steel having more than 0.35 percent carbon. Okay. Now, other than that, see, I'm trying to give you points which, as a designer, as a quality, or as a production, we need to remember. Okay. So first, what we saw, if I have to see what is the acceptable material, I'll go to the table. I can find out my material. Okay. If it is not, then also there is process, but it's tricky. Now, the second part, we can use 36, SA 36 and 283 as a pressure part. Anytime you guys have used that, have you used, I'm talking about pressure vessel, not the tanks. In tank, always we use 36 or 283 storage tanks designed as per API 650. But I'm pretty sure none of you might have used 36 or 283. So 36 and 283 also may be used for pressure part, but there are limitations. Okay. If I have lethal substance, we cannot use it. Okay. Unfired steam boilers, if it is a boiler, then also it's prohibited. Okay. If my thickness of plate by design is greater than 16 mm, I cannot use it. Okay. So these are the limitations which code says. Apart from that, we are free to use that. Okay. Now, this is table UCS 23 for you. So here you will be able to see, you will be able to find your different grades, okay, which can be used. Okay. So I have highlighted the ones which we typically use. Okay. So 106, 179, 192, these are the materials which we typically use. Okay. Like SA 53, that is also a pipe material like 106. Okay. But we never use that as a nozzle. SA 53 we use for structural items like handrail. Okay. So there or any attachment which is external, we can use SA 53. But for nozzles, which is a pressure part, we use 106. Okay. 234 for 179 for tube, 266 for forgings, 234 for fittings, 283 pressure part, a plate or a structural item. 333, what is 333? Anyone? SA 333 pipe. Absolutely right. When we use SA 333 pipe, LTCS pipe. Yes, because it has very good, because why we prefer low 333 for low temperature? What is the reason? Impact, better impact properties. Yes. Okay. So similarly, the 350 LF2 you see, that is also forging material. And if there is low temperature requirement, then we go for SA 350 forging. Okay. For good toughness, good impact properties. Okay.
For in-depth training. And to learn more about these courses, register with the link in the description.